the matrix multiplication application I showed you, you can also use this, but what you do is that the service demand is for the entire application. When you break it into different tasks, if you want to make these tasks homogeneous, you just divide the time among the numbers of the tasks. If your job requires 3 virtual machines, let's say, and the job needs 9 minutes to complete, each task will have 3 minutes. If you want some tasks should take more, then you can actually use a number between 0 and 9 and then randomly assign. Then this number has to add to 9. The total tasks, that the total number you assign randomly, one can take 5 minutes, the other can take 2 minutes, 7, the other can take 2 minutes. One can take 4 minutes, the other can take 3, the other can take. If you want that they are not equal, this is real case. So this is how we model applications. When we divide them, this is how we divide. If we want them, they all do the same thing, equal amount, we give them equal amount. If we believe that they do different amount, then we actually assign them accordingly. All tasks will have the same arrival time because the job arrived at the same time, and then the job is partitioned into different tasks. Usually, we use random. We assign the virtual machine the number of virtual machines you need randomly. But tomorrow I will show you, or we'll talk about, how we can actually assign, choose. You see, there are now small, medium, or large. So we want to actually also use, similar to service demand, how we partition the time. We can also select for each task, whether or for the job, one big or one small virtual machines. Again, the arrival time for all of them is the same. It is only as the scheduler uses the arrival time to discriminate between different jobs. Now, how do we do? How do we actually model? Most of the time, as I said, VM is randomly, you can choose. The arrival time is we use Bayesian distributions. This is really approximates the arrival of jobs into the queue, into the system. A lot of people use this. I use this most of the time. So what we're going to do today is not just, we first create just for one, we model one job, but really what we want to do is we want to submit a lot of jobs. So we loop and create a lot of them, and you will see that some of them arrive. You need to actually do start time from 0 and then increment. But you will see that some of them will arrive at different times. So if you get some value, you start 0, 0 plus that value, or is the distribution that you got, that is the first arrival. The second arrival will be plus of what the time now you have, so it increments like this. This is how we model job arrivals into the queue or into the system. Now, this gives a nice opportunity for each job. Sometimes you'll see they may have very small, or in fact close to one another, because you're generating a distribution, right? Sometimes you get big gaps, sometimes very small. And the second one, if we can start with arrival time modeling, and then we do the virtual machine, the number of virtual machine, and then we'll do the service demand. Okay? Anybody knows the formula for Bayesian? Job A, arrival equal to what? Yeah, so minus lambda is what? Rate, huh? Arrival rate? Yeah. Yeah, that's correct. So we need to write a Java program within Aneka or CloudSim to actually just simulate this. Just write one job for one job, and then we do it for 3, and then we go and also do virtual machines. So the virtual machines for now, we simply say this job will need any number from 0 to 10 virtual machines. Every job, so we wanted to randomly select between 0 to 10. For now, let us assume all the virtual machines are equal, okay, not small size or large, but equal size. It will just tell us how many virtual machines we assign to this job.